Organic chemistry is the study of the structures, the properties, and the reactions of carbon-based compounds. Carbon is what most would consider as the main ingredient in biodiversity or biology in the sense. It's also the main ingredient in making carbon-based compounds, hence the name carbon-based. But what is carbon? Looking at the illustration on the board, carbon is a chemical element with the symbol C, or represented by C. It has an atomic number of 6, as you can see right there. It is also non-metallic, surprisingly, and it is also tetravalent, which means it has 4 available electrons to form covalent bonds, as represented by the lines around the carbon. But if you were to look at it in a biological perspective, it is what practically all living things are made of. And now with those definitions out of the way, we can go back to the definition of organic chemistry, where I stated that organic chemistry is the study of the structures, the properties, and the reactions of carbon-based compounds. Now these carbon-based compounds are further classified into what we call functional groups. Functional groups are a group of atoms that characterize the structure of a family of organic compounds. That is the basic definition of what a functional group is. For this video, however, I will be specifically focusing on 3 functional groups, namely alcohol, aldehyde, and ketones. Now before we start actually defining what alcohol, aldehyde, and ketone are, I will be first giving you guys a foreword on how to actually name organic compounds. Now first, you would need to take into account the prefixes that you need to use when you're going to be naming organic compounds. Now when you're going to be naming such organic compounds, you would first need to take into account the prefixes that you need to use. So when you have 1 carbon present, you would be using meth. This would mean there is 1 carbon present. If you have 2 carbons present, you would be using eth. If there are 3 carbons, you would be using prop. If there are 4 carbons, which in this case we actually do, you will use prefix but. If you have 5, you will use pent. If you have 6, use hex. If you have 7, use hept. And so on and so forth. You may search in Google Images of the actual prefixes that you need to use when you're going to be naming such organic compounds. It is what we call the IUPAC nomenclature. So now that we have the prefixes out of the way, we will now move on to the actual suffixes that you need to use when you're going to be naming this compound. Now, in organic chemistry, we actually have 3 different bonds that are signified by 3 different suffixes. If your organic compound has single bonds all throughout, or just basically a single bond all throughout it, you would be using the suffix called ame. This signifies that there are only single bonds present in the organic compound. If there is a double bond, however, that is present, you would be using the suffix "-ine" instead of "-ane". This would mean that there is a double bond present in your organic compound. If there is a triple bond, however, present in your organic compound, that would mean you would be using the suffix "-ine". These three will come in handy when you're going to be naming such organic compounds, as this will signify how many bonds are actually present, or what bond is actually present in your organic compound. So now that we have that out of the way, we can now move on to the actual first functional group that we need to discuss, which is alcohol. Now, alcohol is an attachment wherein it is represented by the hydroxyl group, which is OH, which is an attachment to a carbon atom. This carbon atom is attached to the mother chain, which is the longest chain in the organic compound. This would mean that the hydroxyl group, which is the OH or the alcohol, is an attachment to the mother chain. When you're naming alcohols, you will be replacing the suffix. If let's say that your organic compound is a single bond all throughout, that would mean the suffix is "-ane". But if there is an attachment of a hydroxyl group or alcohol, you will be replacing it with OL to represent alcohol. If, however, there are more than one hydroxyl group present, you will be adding to the suffix to include a prefix that indicates the number of hydroxyl groups that are present. So let's say that your organic compound has 2 hydroxyl groups present. That would make it, and keeping in mind that your organic compound still has a single bond all throughout, there is no double bond or triple bond, you would be using "-ane-di-o". Di, because there are 2 alcohol or hydroxyl group attachments present in the organic compound, and "-ane" because there is single bonds all throughout the organic compound. Here is another example that we have, wherein we have 2 hydroxyl group attachments now. Now, like I said before, when there are 1 or 2 or more hydroxyl group attachments, you will be adding a prefix to the suffix that you have to signify how many hydroxyl groups attachments are present in the compound. In this case, we have 2. So again, when you're naming it, you will be counting from left to right or right to left. It doesn't really matter since they are both the same. But in this case, I will be counting from left to right. So this is my 1, 2, 3, and then 4. My first attachment is on the second carbon, and my second attachment is on the third. So I will be writing that down. First, it's obviously 2, then 3, and then we have 4 carbons in the mother chain. So we will be using the prefix "-bute" to signify 4 carbons. And since it is a single bond, we will be using "-ane", or in this case, we will just be using "-an". Now we have 2 hydroxyl group attachments, so that means that we will need to add a prefix to the suffix, or the original suffix, which is "-ol", to signify how many hydroxyl group attachments do we have. So in this case, we have 2, so that would mean we will be using "di" to signify that there are 2, because "di" means 2, and then you just add "ol" as the final suffix. And just like that, we have named this compound, which is 2,3-butane-di-ol. We also need to take into account 3 different classifications of alcohols. In this case, we have the first one, which is what we call a primary, wherein the alcohol group is connected to one carbon, or in this case the edge or the furthest carbon, or the carbon that is on the edge of the group or the organic compound. This is what we call primary. Second, we have the secondary, which is represented by the hydroxyl group being in one of the middle carbons in the chain. That is what we call secondary. And lastly, we have tertiary, wherein the carbon is connected to 4 carbons here. And if we go back to the definition of a carbon, it is tetravalent, which means it has 4 bonds, and it is showcased here where one carbon has 4 connections, one being the alcohol group, another being a carbon, which is one of the carbons in the mother chain, another carbon which is in the mother chain, and a attachment carbon. That would be tertiary. Here is one example of a primary alcohol, wherein it is connected to the first carbon, since when you're going to be counting it, you count to where the functional group is nearest to. In this case, the first carbon, which is where the alcohol group is connected to, will be your first, and then the following will be your second, third, and fourth, so on and so forth. When you're naming it, it's basically ethanol, or ethanol, my bad. It's ethanol, because since there are 2 carbons, and an, as it is only connected by single bonds, and since there is an attachment here, which is the alcohol, we use the suffix "ol." Hence, we have the name ethanol. Here is an example of what you call a secondary, wherein the alcohol group or the hydroxyl group is connected to one of the middle carbons. In this case, the hydroxyl group is connected to the second carbon, which is in the middle. So when you're going to be counting, it doesn't really matter since it is equal on both sides. So let's say that I count from here, here, and here. So from right to left. It's 1, 2, and 3. When you're going to be naming it, since there are 3 carbons in the mother chain, you will be using the prefix prop. But since we have the attachment connected to the second carbon, we're going to be naming the number first, which is 2, since the hydroxyl group is connected to the second carbon. And since we have 3 in the mother chain, we use prop as our prefix, and as these are connected by single bonds, we use "-ane" as to signify that it is single bond connected. And lastly, we use the suffix "-ol" to have to signify that there is a hydroxyl group attachment. So now we name it as 2-propanol. 2 being the hydroxyl group to where the hydroxyl group is attached. Prop, since there are 3 main carbons in the mother chain, and as it is connected by single bonds, and "-ol" to signify that there is a hydroxyl group attachment. And here we have an example of a tertiary, where the hydroxyl group is connected to a carbon which is connected, or which has a attachment of another carbon, which is what we call a methyl. Now again, the mother chain is the longest chain of carbons that is present. In this case, we have this as the mother chain, since it has 4 main carbons. And when there are 4, we use the prefix "but". So now we're going to be starting to naming it. In this case, we start naming it with the attachments first. Now the hydroxyl group and the methyl is connected on the second carbon. So that would mean you would be using 2. But since both of them are connected in the same carbon, we will be repeating it the same way to signify that there are two connections in the second carbon, because if you're going to be using only one, it will cause some confusion as to your naming. So since both the attachments are connected in the second carbon, you will be using 2 to signify the first one and another 2 to signify the second attachment. So now we have 2, 2, and since we have 4 carbons, we use but as our prefix, and since it is a single bond, we will be using an as our to signify that there are only single bonds, and finally the suffix "ol" to signify that it is alcohol. So our final name is 2,2-butanol. Now here we have a much more complex example of an alcohol which involves a enclosed structure. Now this may seem scary at first, but actually it is very easy to name. So again, let's take into account the different attachments first, or the total attachments present in the structure. We actually have 3. We have 2 hydroxyl group attachments and 1 ethyl attachment, represented by the 2 carbons that are right here. This is 1 carbon, and this is another carbon right there. So with that in mind, we need to start counting now. Or actually the question is, where should we start counting? Now we start counting to where the functional or the whole structure has become functional first. In this case, this structure became functional at this carbon because this is where it started. And then your number 2 would be here. This is because there's another functional group attached to this structure, this enclosed structure, and is near to the first carbon, or to where the structure has started to become functional. We can't count counterclockwise, or clockwise rather. We can't count like 1, 2, 3, 4. That doesn't work, because there are 2 carbons right here that separate this functional group to this one, or this attachment to this attachment. As opposed to here, it is not separated by any carbon, and it only has 1 carbon directly right after the first carbon. So when you're going to be counting, this is where you will be starting. This is your 1, your 2, your 3, your 4, your 5, and then your 6. You will not be counting clockwise, which is 1, 2, 3, 4, because there are 2 carbons here that don't have attachments. If we count clockwise, this second carbon right here doesn't even have an attachment. While if we count counterclockwise, there is an attachment on this carbon here, which makes it the second carbon. So with that in mind, the first hydroxyl group is connected to the first carbon, the second hydroxyl group is connected to the second carbon, and the ethyl attachment is connected to the fourth carbon. So with that, now we can start naming it. So first, we start naming the attachments first. In this case, you'll be naming this one first, because these 2 will be attached to the parent chain itself when you're going to be naming it. So this attachment is connected to the fourth carbon, so we write down 4 to signify that this attachment is on the fourth carbon, and we put a hyphen right there, or dash. Now since it has 2 carbons right there, it is called an ethyl attachment, so we write down ethyl. And just like that, we've named that attachment. Now we move on to these 2. Now again, the first hydroxyl group is connected with the first carbon, and the second hydroxyl group is connected to the second carbon. So we write down 1, 2. This is because, again, we have the 2 of the same attachments. So now we have 1 to signify that this hydroxyl group is connected to the first, and this one is 2, which is connected to the second carbon. Now we put a hyphen right there because we've already put the number or assigned the numbers for each hydroxyl group. Now this structure is what you would call a cycle, which is basically an enclosed structure. If it's an open chain, it will not look like this. An open chain would look something like that. That is an open chain. This is an enclosed chain, which we'll be using the prefix called cyclo. So we write down cyclo right there to signify that it is an enclosed chain. And since it is connected by single bonds all throughout, it doesn't have a triple bond or double bond or whatever, it's only connected by single bonds, we use, since it is a single bond, we use ane as our suffix. We use that, keep that in mind, we use ane. And since we have 6 carbons in total in the enclosed structure, there's 1, 2, 3, 4, 5, 6, we use hex as our prefix. And we just combine these two together. Hex because there are 6 carbons, ane because it is connected by single bonds. So it's going to be cyclohexane. Now since there are 2 hydroxyl groups and we haven't named them yet, we use the prefix di to signify that there are 2 hydroxyl groups and our suffix ol to signify it is an alcohol. So we write that down at the end, di. I'll be writing it down here, it's going to be diol. And just like that, we've named this structure, which is 4-ethyl because it is this attachment, this ethyl attachment is connected to the 4th carbon. 1,2 because these hydroxyl groups are connected to the 1st and the 2nd carbon. Cyclo because it is an enclosed chain. Hex because there are 6 carbons in total. Ane because it's connected by single bonds all throughout. Di because there are 2 hydroxyl group attachments. And ol because it is an alcohol. And now we move on to aldehyde. Now, when you're talking about aldehyde, all you really need to do is take into account the mother chain or the number of carbons in the mother chain. Say for example you have 5 carbons in the mother chain, that would mean, and they are connected by single bonds, it would mean it is pentane, right? Since there are 5 carbons, pent, and it is connected by single bonds, which is ane. When you're going to be naming the aldehyde, you replace the e with al, or the suffix al, and it would look something like that. So instead of e, you replace it with the suffix al or al to signify it is an aldehyde. Previously in alcohol, we had the attachment represented by the hydroxyl group OH. As for aldehyde, however, it is represented by the attachments as a double bonded O and a single bonded hydrogen. Conveniently enough, however, it actually follows the same naming rule as alcohol. So if there are more than 2, or more than one actually, more than one functional group or aldehyde group, you name it with a prefix to define how many groups are, or functional group is present in that compound. So if there are 2, then you use the prefix di and then al. Dial. Al as it signifies that it is an aldehyde. However, unlike alcohol, you do not need to name the number when you're naming the whole compound, as the oxygen attachment or the double bonded oxygen attachment and the hydrogen attachment is always on the first carbon, no matter what. Here's an example to further demonstrate. So let's say that your mother chain has 3 carbons and you have a attachment which is oxygen. When you have this, since this oxygen or double bonded oxygen is what you call a functional group, you start counting from this carbon first. This is not a carbon, as it's already explicitly stated or drawn there, it is oxygen and not a carbon. So that would mean your carbon is right here. So that's 1, 2, and 3. Don't let this deceive you, however. This is only a double bond to oxygen and not to the mother chain itself. The mother chain itself only consists of 3 carbons that are connected by single bonds. So, with that in mind, unlike alcohol, you don't need to name the number to where the attachment is attached because it's always on the first carbon no matter what. So in this case, all we really need to do is name the mother chain, which is prop, to signify that there are 3. Since it is connected by single bonds, you use ane or an, and since there is an aldehyde attachment or double bonded oxygen attachment, you use the suffix al. And now you have the compound propanal. And we're done with aldehydes. And with that, we move on to the last one, which is ketones. Now, ketones is basically the same as aldehyde, but it's not on the first carbon. The double bonded oxygen can be in any carbon in the middle of the chain. So that would mean if in aldehyde the double bonded oxygen is connected to the first carbon, so it's connected like that, like that, it's connected to the first carbon, a ketone has the double bonded oxygen in one of the middle carbons. That is their striking difference. When you're going to be naming ketones, you use the suffix "-one", as the name suggests. It is a ketone. So this will be your suffix, your main suffix, when you're going to be naming ketones. Just to review, if you're going to be naming aldehydes, you use the suffix "al". And we're going to be using alcohol, or using a suffix for alcohol, you will be using the suffix "ol" or "ol". Here we have an example of a ketone where it has 2 attachments in the middle carbons, and this is what I've been saying a while ago. If in aldehyde you have the attachment connected in the first carbon, in a ketone you have it in either one or more of the middle carbons. So now we're going to be counting first so we can find out which carbons are the attachments connected to. So in this case, we have 5 in the mother chain, which is 1, 2, 3, 4, 5, which is a pentane, since it is connected by single bonds. But since it is equally distributed or equally on the same side, it doesn't really matter where you count. So you can count from the left, you can count from the right, and it would still give you the same result. But in this case, I will be counting from left to right because why not? So we have 1, 2, 3, 4, and then 5. The attachments are connected on the second and the fourth carbon. So we write down the numbers first, of course. So we have 2 and then 4. That would signify that there are 2 attachments connected to it. And since this is a pentane, you write down pentane. Pentane. There you go, pentane. Now since there are 2 attachments there, we signify it with adding a prefix to see that, or to signify that there are actually 2 attachments or 2 ketone attachments. So that would mean we would be using the prefix di, and then our suffix, or the main suffix that we need to use for ketone, which is on. Dione. And there you go. We've successfully named it, which is 2,4-pentane dione. 2,4 because there is a attachment on the second and the fourth carbon. Pentane because it is a single bonded. There are 5 carbons which are connected by single bonds. Di because there are 2 attachments, and one which is signify that it is actually a ketone. And with that, we can formally end our informational video about alcohol, aldehyde, and ketone. I do hope that you guys understood and got some information on and further insight on what organic chemistry is, what functional groups are, and specifically what alcohol, aldehyde, and ketone is all about. And with that, I will formally end my informational video, and I greet everyone a good morning, afternoon, or evening, or whenever you are watching this video. Thank you, and I hope to see you again in another informational video about organic chemistry.